So on this situation, it's a little bit different because they gave us the graph this time and we have to come up with an equation, the verbal description, and make our table. So we would have to do like what we always do with finding our y-intercept and our slope. So I'm just going to put that up here. Our m is our rise over run. Our b is our y-intercept, which is always easy to identify. So I always look at my y-axis to identify my y-intercept, which it hits it right there, so I know it is 20. I don't like counting in between perfect like crosshairs of dots, so I'm going to go ahead and use this. So notice my scale is going by 20. So when I'm rising 20, 40, 60. And I am running 1, 2. If I simplify 60 over 2, that gives me 30. So let me move this over. So this gives me 30. I know my b is 20. So when I go to write my equation, my y equals mx plus b equation, I have y equals 30x plus 20. So the situation up here tells us that he charges a certain amount for the house call itself, like the base amount, like just to show up. And then he charges a certain amount hourly for each hour he's there. So if we want to write our verbal description, we know that that $30, because it's associated with the X, it's our rate. So that's what's going to be the hourly charge. And then that $20 is what it cost him to even show up. So Andy's appliance repair charges $20 to show up and $30 per hour for repairs. So then if we want to go do our table, again, I kind of filled it in to save a little bit of time. So you may have to pause this and fill in your table. So I know if he shows up for 0 hours, if I do 30 times 0, that's 0. So if for him just to show up and he's spent no time at your house, just for him to show up, it's going to cost you $20. After 1 hour, I'm going to have that $20 that it cost him to show up plus $30 for that first hour he's there, so I know it's going to be $50. After 2 hours, it's that $20 for him to show up plus $60 that the $20 for him to show up plus the 60 hours for him to be there. So I know that's $80. And then I'm going to have 110. And notice I am changing because I'm only increasing by 1 hour at a time over here. I am increasing by $30 for every hour. So just like even over here, you can tell like I increase by $30 for every hour, increase $30 every hour, $30 every hour, $30 every hour, 30. So I'm increasing on my graph for $30 every hour, and on my table, I'm increasing by $30 every hour. So for 4 hours, I know it's going to be 140. 5 hours, it's going to be 170. 6 hours, it's going to be $200. So I'm hoping that you're starting to realize like the relationship between how my equation works with my rate of change and how that is just exactly what my slope is on my table and how that's how I'm changing on my graph as well. So let's answer some of the questions down here. What is the slope of the graph and what does it represent? So the slope is 30. The slope is 30, and that is his hourly rate. The y-intercept is 20, and that is that's the cost for him to show up. And then again, so my x value is hours and my y value is total cost. So this is x and this is y. So I know that the ordered pair that for it after 10 hours, it will cost $320. So if I want to know a 9-hour repair, I can use my equation y equals 30x plus 20, and then just substitute 9 in for x because hours are my x value. So y is equal to 30 times 9 plus 20. So you would end up with y equaling $290. And then if I wanted to know how long it would take a cost of $470, I would again use my equation y equals 30x plus 20 and have 470 is equal to 30x plus 20, take away 20, take away 20 because I'm solving for x, so I get 450 is equal to 30x, divide by 30, divide by 30, and so I know x, it would take 15 hours. So you have a couple of situations here to try and do. Again, try them. If you are struggling, there's a key on the website. I would say pick one of these two to do. You can pick either one to do so that you don't spend too much time on it. If you want to do both, you can. But if you're feeling like this is taking too much time, pick one of the two to do. And then this shouldn't take you too long to do. You have 3 equations and I want you to find the matching table and graph that goes with them.